Okay, grade 12. So let's answer those extra few questions that I gave you. I hope that you realize that up until now, you've been dealing pretty much with things that look like this. I want to just discuss the importance of why it's always looked like this so that we can see what's different here. So up until now, it's pretty much been like this. Occasionally, we've left out a term, maybe the x squared term, but pretty much you would have noticed that everything has always remained in descending order with regards to the exponents of the variable. So if we have a look at this very first example here, you'll notice that it has an x cubed, then an x, then an x squared. So these are not in descending order. So my suggestion is the very first thing you want to do is write them in descending order, just because it is going to make your synthetic division a lot easier. And I hope that you see that now you can spot quite quickly that you're missing your constant. So we need to remember that when we do our synthetic division. Now, for the rest of it, we're just going to carry on as we always have. So let's start where x is equal to 1. So we're going to sub in x is equal to 1. So we'll get f of 1 is equal to 2 times 1 cubed minus 14, 1 squared, plus 24 times 1, and you get that that is not equal to 0. And then we're going to be on to the next one, which will be minus 1, and we will actually see that f of minus 1 is also not equal to 0. So we carry on, and we go on to 2, and we see that f of 2 is also not equal to 0. And so we just keep going, guys. It's pretty rare that you'll get something like this where you've gone all the way up to -2 and it's not equal to 0. But if it does happen, it's not the end of the world. All right. So the next thing is we'll try when x is equal to 3. We'll get 2 times 3 cubed minus 14, 3 squared plus 24 times 3. And finally, we reach that it equals 0. So from here, we need to remember that that means that x is equal to 3 is a solution. But then that also means that x minus 3 is our linear factor. All right. Okay, so now we found our solution we can do. So we're going to do our synthetic division. So let's draw our little synthetic division box. And we pop down our solution over here. Now, this is why it's important to make sure that everything was in descending order. So you want the one for x cubed first. Then you want the one for x squared. Then you want the one for x. And then you want your constant. In this case, we'll just call it d. Alrighty. So the coefficient for x cubed is 2. The coefficient for x squared is minus 14. The coefficient for x is 24. And then we're going to be very careful to write that our constant is 0. We're not going to leave that out. All right, then we should just get to it. We bring down this 2. 3 times 2 is 6, positive 6. Minus 14 plus 6 should give us minus 8. 3 times minus 8 is minus 24, which gives us 0. 3 times 0 is 0, which should give us that golden 0 at the bottom there. So from there, what we have is that that means that fx, we know the linear factor from right over here is x minus 3. And then we're going to put in our quadratic factor. So because this one was x cubed, this one is going to be x squared. Because this one was x squared, this is going to be x. And because this was x, it's now going to be our new constant. Alrighty, so let's put this down to x squared minus 8x plus 0. So I'm just going to close it right there. Now you might be tempted to stop, but you haven't fully factorized, because if we look back at our basics of factorization, we see that we can pull out a common factor here. And I hope that you can see that the common factor is 2x. So I'm going to take out a 2x from here. I'm going to leave this first bracket as it is. And if I take out a 2x from here, I'm left with just an x minus, take out a 2x from here, and I'm left with a 4. So that is the answer to our first question, well, question number 2 there, the first additional question. Alrighty, so now let's have a look at the second one and let's see why this one is unique. Like I said before, you would have had this format and we usually left out the x squared term. But it's not necessarily the only way that they can do it. If you have a look here, you've got an x cubed, you've got an x squared, and you've got a constant. So you are missing an x term, which means that its coefficient is 0. So we just need to remember that, but from here we can pretty much just carry on as is. So let's start with x equals 1. We're going to get g of 1 is equal to 1 cubed. Oh, I should put my brackets in now. 1 cubed minus 3 times 1 squared plus 4, which unfortunately does not give me 0. 1 minus 3 plus 4 doesn't give me 0. So let's try our next option. So we're going to do g of minus 1, which is equal to minus 1 cubed minus 3 times minus 1 squared plus 4. And then we're going to get from here minus 1 minus 3 plus 4, which eureka is 0. Once again, I'm just going to write it on the side here. This means that x equals minus 1 is a solution. You'll notice that I'm constantly reiterating this for a reason. That means that x plus 1 is our factor, our linear factor. Alrighty, so now that we found our solution and our factor, what we can do is move on to our synthetic division. So I'm going to draw my box here. I'm going to put down my solution, which I need to remember is minus 1. Now I need to recall that this has to be the coefficient of x cubed, the coefficient of x squared, the coefficient of x, and the coefficient of my constant. So let's go for it. The coefficient of x cubed, I hope you see, is a 1. The coefficient of x squared is minus 3. The coefficient of x, well, we've just put that bit of information, so we need to remember it is 0. And then our constant is 4. So now we can carry on. So let's bring this down and multiply. Negative 1 times 1 is negative 1. Negative 3 minus 1 is negative 4. Negative 1 times negative 4 is positive 4. 0 plus 4, quick math, positive 4. Minus 1 times 4 is negative 4, which, thank goodness, gives us that golden number. Now, what I want to do here in green is just show you what would happen if you forgot to put the 0. So let's draw our little synthetic division box and say we just forgot to put this in, and we're, oopsies, say we forgot to add that 0 in. Let's see what this would look like. Okay, so we put 1, we put minus 3, and then we put 4. Okay, so let's try it and see what we get. Bring down this 1, times them, we're going to get minus 1, and then we negative 3 minus 1 is negative 4. Negative 1 times negative 4 is positive 4, and 4 plus 4 is 8. Do you see how you did not get your 0 here? So that should be an immediate indicator that something we did there was incorrect. All right, so let's carry on with our magical correct answer over here. So now we know that g of x, the one factor we said was, or the linear factor rather, was x plus 1. And now because this was x cubed, this one is going to be x squared. Because this was x squared, that'll be x. Because that was x, it'll be the constant. So now we've got 1x squared minus 4x plus 4. And again, any form of factorization you want to use here, you're welcome to, but I'm feeling pretty okay with this one. So I'm going to say x minus 2, x minus 2. Negative 2 times negative 2 will give me positive 4. Minus 2 will give me negative 4. But again, just because I want to make it look really neat, really tidy, really mathematically accurate, I'm just going to simplify it to x plus 1, x minus 2 squared, because these two are identical. And that'll be your answer for this question. So here's the things that I want you to notice. You need to make sure that your exponents for the variable are in descending order, just so you're sure you're using the correct one. And then here, always check that you're not missing any of them. If you are, remember to make that coefficient a 0. Otherwise, you will probably, definitely get the incorrect answer by using this method. All right, so now we're going to get to this one. This one was a bit of a cheeky question. It is sort of my way of showing you that using this method, you're basically able to factorize any order of polynomial. So here I've gone up to the 4th order, but genuinely you could factorize a 5th, a 6th, a 7th, etc., etc. It would just start getting very long. But I just wanted to see if you could extend the foundation of this and apply it to a higher order polynomial. All right. So it's unlikely that they would ask you something like this, but just in case they did, for maybe a problem solving or a more complex type one, we could factorize it. So I'm going to follow the same exact steps that I would anyway for a cubic polynomial. So let's start with finding a value of x that will make hx equal to 0. So let's start with h1 is going to give me 3 times 1 to the power of 4 plus 3 times 1 cubed minus 8 times 1 squared minus 2 times 1 plus 4. Alrighty. So from here we'll get 3 plus 3 minus 8 minus 2 plus 4. And yay, that is going to equal to 0. So now we're going to say that x equals 1 is our solution and that x minus 1 is our linear, oopsies, our linear factor. Now, previously with a cubic polynomial, what you had was you had a linear factor and then a quadratic. Now what you're going to get is a linear factor and then a cubic factor. And here's the thing, then you're going to have to factorize that cubic factor, but you already know how to do that. So let's try this. Let's show you what I mean. All right. So I'm going to draw a nice long box here. I know my solution is 1. I have x to the 4, x to the 3, x squared, x, and a constant. So it is in descending order, and I'm not missing any of those. So let's write this. It's 3, 3, negative 8, negative 2, and 4. So in case you missed it, this is the coefficient for x to the 4. This is the coefficient for x to the 3, x squared, x, and the constant, which in this case I'll just call e. Alrighty, so now we're going to follow the same exact process and let's see how it goes. Bring down the first one and let's start multiplying. 1 times 3 is 3. 3 plus 3 is 6. 1 times 6 is 6. Negative 8 plus 6, so if you need to put that there for your own sanity, is minus 2. 1 times minus 2 is minus 2. Please remember that minus 2 is minus 4. 1 times minus 4 is minus 4. And would you look at that? 4 minus 4 is 0. So we're already headed in the right direction here. So now we've got x minus 1 was our linear factor. And from here, just like before, previously we would have an x cubed and this would become x squared. So because we have an x to the 4, this becomes x cubed, this one is x squared, this one is x, and this one is a constant. Alrighty, I'm not sure why that e looks that way, but we can leave it be. Okay, so now instead of having a quadratic, you're going to have a cubic. I hope that that made some sense. It's pretty much just continuing on from what we saw. Okay, but we're not quite done yet. You remember when we had a cubic, we still had to factorize the second one. Well, guess what? We have to factorize this cubic one. And you know exactly how to factorize it. You're going to find a value of x that makes this whole situation equal 0. So let's try x equals 1, and we're going to get 3 times 1 cubed plus 6 times 1 squared minus 2 times 1 minus 4, and sad, it doesn't equal 0. Then we're going to try x equals -1, and we're going to do the same sort of thing, and we're going to be very sad because it doesn't equal 0. And then we're going to keep going, and we're going to try 2, and we're going to be even more sad because it doesn't equal 0. And then we're going to try x is equal to -2. I have a feeling about this one, guys. Okay, so -2, I don't know why that minus looks that way, but there it is, plus 6 times -2 squared, -2 times -2, -4, and we're going to get 3 times -8, plus 6 times 4, plus 4 minus 4, and this is going to give us 0. Yay! So now for this portion over here, just this cubic portion, we can now see that x equals -2 is a solution, and x plus 2 is going to be a factor. So for this cubic polynomial portion, we're going to do synthetic division once again. We're going to pop down all of those coefficients, which are 3, 6, -2, and -4. Alrighty, so we drop this down. -2 times 3 is -6. 6 minus 6 is 0. -2 times that is 0. -2 plus 0 is -2. -2 times -2 is +4, which gives us the winning 0 over here. So now we can say the following. We need to remember that this is what we had originally, okay? So we can actually say now that hx is equal to x minus 1, and then the linear factor for this part, x plus 2, and now we've got this quadratic here, which would be 3x squared, 0x minus 2. Alrighty, guys, I hope that that made sense to you guys, and we really could just stop right here. So that is how to factorize this polynomial to the 4th power instead of to the 3rd. So there you go, guys. I hope that that was helpful, and I hope that you can answer your questions. Alrighty, bye.